In acute triangle ABC, points P and Q are the feet of the perpendicular from C to AB and B to AC respectively. Line PQ intersects the circumcircle of ABC in two different points, x and y. Suppose xp equals 10, pq equals 25, and qy equals 15. The value of AB times AC can be written in the form m root n, where m and n are positive integers and n is not divisible by the square of any prime. What is m plus n? We have acute triangle ABC, and we have altitudes CP and BQ onto sides AB and AC respectively. Now we have line PQ, which is given to intersect the circumcircle of ABC in two different points, x and y. We have xp equals 10, pq equals 25, and qy equals 15. Based on this, we want to find AB times AC. If you read EGMO, you might know that PQ is one of the sides of what we call the orthic triangle of triangle ABC, which is formed by connecting the points where the altitudes meet the opposite sides. Two of these points are P and Q. And the sides of the orthic triangle are A cosine A, B cosine B, and C cosine C, where A, B, and C, the lowercase letters, denote the lengths of the sides opposite points A, B, and C respectively. So we know that A cosine A is equal to 25. Let's see if we can find the other sides of the orthic triangle. So assuming I denote the foot of the altitude from A as R, we could use power of a point on P and Q with respect to the circumcircle of ABC. That could help us learn more about the orthic triangle of ABC, which is PQR. So using it on P and the circumcircle of ABC, we get XP times PY, which is 10 times 25 plus 15, or 10 times 40. And that's equal to 400. Now, 400 equals AP times PB. And we can express this in terms of the sides of ABC and the angles of ABC. For AP, if you use right triangle APC, you'll see that AP is equal to AC times the cosine of angle A. And that's just B cosine A. And PB is just BC times the cosine of angle B, which is just A cosine B. So we have 400 equals B cosine A times A cosine B, which can be rearranged into A cosine A times B cosine B. And we know A cosine A is 25. So we can write 400 equals 25 times B cosine B, which is just PR. And so we have PR equals 16. So we can label this as 16. We can do a similar reasoning for point Q. We have XQ times QY, which is equal to 35 times 15. And that's equal to 525. So we have 525 equals AQ times QC. And AQ, using right triangle AQB, that's just AB times cosine A. And that's just C cosine A. And similarly, QC is going to be A cosine C. So we have rearranging, this is equal to A cosine A times C cosine C. And now we know A cosine A is 25, so C cosine C is 525 over 25, which is just 21. And that's equal to QR. So we can write QR equals 21. So now we know all three sides of the orthic triangle of ABC. The question is now reduced to if PQR is the orthic triangle of ABC with side lengths 16, 21, and 25, then what is AB times AC? So we know that the side lengths of triangle PQR are PQ equals 25, QR equals 21, and PR equals 16. So we know all three angles of PQR, which we can get using the law of cosines. And that can allow us to learn more about the angles of ABC, because the angles of the orthic triangle are just 180 minus 2A, 180 minus 2B, and 180 minus 2C respectively, which you should know if you've read EGMO. So since angle P, for example, equals 180 minus 2C, we have angle P plus 2 times angle C equals 180. So 2 times angle C is 180 minus angle P. And so we know angle C is just 90 minus angle P over 2. The same goes for B and A. angle B is equal to 90 minus angle Q over 2, and angle A equals 90 minus angle R over 2. So those are angle A, B, and C in terms of P, Q, and R. Now, let's find the angles of triangle PQR using the law of cosines. So first, we have angle P. The cosine of angle P is equal to 25 squared plus 16 squared minus 21 squared over 2 times 25 times 16. And that is equal to 625 plus 256 is 881 minus 441 is 440 over 2 times 400 is 800. So 440 over 800, that's just 11 over 20. Now cosine Q, that's equal to 25 squared plus 21 squared minus 16 squared over 2 times 25 times 21, which is equal to 625 plus 441 minus 256. That's 1066 minus 256, which is 810. So 810 over 2 times 21 times 25. And 2 times 21 is 42. 42 times 25 is 1050. So 810 over 1050, that's just 27 over 35. And now for cosine R, well, cosine R is equal to 16 squared plus 21 squared minus 25 squared over 2 times 16 times 21. And that's equal to 256 plus 441, which is 697, minus 625, and that's 72, over 2 times 336, which is 672. 72 over 672, that's 3 over 28. So now we found all three angles of triangle PQR. What do we want to find? We want to find AB times AC, which can be simply denoted as B times C. So I'll write it that way. We want B times C. And in terms of the sides of triangle PQR, well, B cosine B and C cosine C are sides of triangle PQR. So we can express this as B cosine B times C cosine C over cosine B times cosine C. And we know B cosine B and C cosine C, they're 16 and 21 respectively. So 16 times 21 is 336 over cosine B times cosine C. So if we can get the cosines of angles B and C, then we're pretty much done. And we know that angle B is just 90 minus angle Q over 2, and angle C is 90 minus P over 2. We can write this as 336 over the cosine of 90 minus Q over 2 times cosine of 90 minus P over 2. And that's just 336 over sine P over 2, sine Q over 2. And we know the values of cosine P and cosine Q. We can use the half angle formula, which directly involves the values of cosine P and cosine Q for sine of P over 2 and sine of Q over 2, and then we're done. So sine P over 2 is just the square root of 1 minus cosine P over 2. And that's equal to the square root of 1 minus 11 over 20 over 2. And that's 9 over 20 divided by 2. So we have the square root of 9 over 40, which is equal to 3 over 2 root 10. And similarly, sine Q over 2 is equal to the square root of 1 minus cosine Q over 2 by the half angle formula. That's equal to 1 minus 27 over 35 is 8 over 35. So if we divide that by 2, we get the square root of 4 over 35. And that's just 2 over root 35. So we want 336 over the product of these two numbers. So 336 over the number 6 divided by 2 root 10 times root 35. And that's 336 over 6 is 56 times 2 root 10 times 35 is 350. And that's equal to 112 root 350. We want this in purely simplified form, where n is not divisible by the square of any prime, but in this case 350 is. It's 14 times 5 squared. So if we get rid of the 5 squared by multiplying 112 by 5, we get 560, but at the same time, we have to divide 350 by 5 squared. That's the only way to keep the number equal. So it's 560 root 14. That's equal to AB times AC. It can be written in the form m root n, where m and n are positive integers. M equals 560 and n equals 14. What is m plus n? It is 574. Thank you for watching my YouTube video, and please follow my channel if you would like to see more videos.